So this is weekly contest 269. Let's see how it goes. Okay. Okay, so we're given an array and a target. We have to find an index I such that it is equals to target. Got it. So we have to return the list of. Okay. Mhm. So we have to return the list of indices where the number. Got it. So what do I do? I think. Okay, what if the number is not present only? What you return in that case? Empty. Okay, that's actually good. Okay, I can use one method I think here. Um, Not lower bound. There's a method equal range. Okay. Um, if p dot second minus p dot first. If this is greater than or equal to 0, return p dot second minus a dot begin, comma. Okay, so what I'll do is for int I equals to p dot first minus um, p dot, it's not p, a dot begin, I less than equals to p dot second minus a dot begin, because it gives us a pointer I plus plus answer dot push underscore back I. This will store me the index. Return answer. So vector integer of an answer. I'll see if it is okay or not. I'm saying 1, 2, 3, which is bad. Okay, it gives me an upper bound, right? I less than period second. 1, 2, 3, 4, and empty. Seems good. Accepted. Okay, so we're given an array nums and an integer k. Okay, the k radius average for a subarray of nums. Okay, it's the average of all elements in nums between the index I minus k and I plus k inclusive. Okay, let's see. For this element, mhm. Okay, so this should be easy. Hmm. Can I do it using prefix and suffix? I'll maintain two arrays, one for the sound on the left, prefix of n, and then you have the array of suffix. So, okay, prefix of, what should I say, 0? Okay, let's do one thing. Let's take, no, let's keep it in. Prefix 0 is equals to a of 0. And similarly, suffix of 0 equals to fi minus 1. Okay, so prefix of I, this would be the previous element plus the a of I. Similarly for the suffix array. So this would be suffix of I equals to suffix of I plus 1, because the next element plus a of I, right? Alright, so we start from, let's call it vector in answer. There are n elements. Initialize with -1. Now for int I equals k. Okay, is it correct? K. So I want to start from k. Yeah, that's correct. I equals k. I less than n minus k. Is this correct? N minus k. So this is n minus 1, n minus 2, n minus 3. Seems good, right? Answer of I equals to prefix of I minus 1 minus, we can say, I can just include this here, minus prefix of I minus k. So if k, okay, sorry, sir. So this should be what? I minus, if I minus k is greater than or equal to 0, if this is greater than 0, so what I'll say here, minus k minus 1, I think. Let's think about this first. I'm standing at this index, 1, 2, 3. If only I could go 4 steps. Okay, yeah, seems good. Okay, so answer of I plus equal to, okay, let's call it temp. Okay, so this should be suffix of I plus k. Let me check. 1, 2, 3. Yeah, I plus k minus suffix of I. Divide by 2 times k plus 1, right? 2 times k plus 1. Answer plus equals to, sorry, answer of I equals TLB. This, okay, I'll just simply test this one first before thinking. Okay, it's all wrong. Why? Why is this all wrong? Okay, the very first thing I should do is I should try to, okay, yeah, I less than n, I plus plus, see out, prefix of I, this should print the prefix array, and now I want to do it for both prefix and suffix. Okay, anything else? Yeah, let's just see first of all this, if my errors are getting computed correctly. Yeah, this seems good. Okay, suffix I'm doing wrong. So this should be suffix of, okay, it gives me a negative, right? So I should put a negative sign here. Let's see now. 545. No, this is not correct. 5444, right? 7439185. Let me think about this again. So prefix of I minus, if that value can fit. Okay, so let's see. 43, so 23 and 18. 23 and 18, right? Hmm. Yeah, 23. And it's saying 18 here. Let me think. Oh no, sorry, here. Oh, why this correct now? I don't know. Seems to be correct. Let's just run it once again. 5. Oh no, it's not correct. 544 was the correct value. Okay, 23 and 18 it's saying, right? Let's just see. So for this, 9 plus 3 is 12. 12 plus 4 is 16. 16 plus 7 is 23. Is it correct? Yep. 9. 9 plus 5 is what? 14. I'm getting an 18 for some weird reason. So if I say 37 minus 23, that should be what? 4. Okay, why do I need first of all suffix? Yeah, that's a very silly thing to have because anyway I can compute the differences from prefix itself, right? What am I doing? So this should be what? Prefix of I plus k minus prefix of I. Oh no. Okay, where am I going wrong now? This is not required. 544. Yeah, seems correct now. Yeah, let's comment this. Anything else? Okay, this also. 544 seems correct. No, I should have used long. This should be good, right? Because they're giving us integers, so shouldn't overflow now. Okay, I already have a one ready. Great. Okay, there's the lowest value and an element that is the highest value. Okay. Okay, so this should be easy. All element at this rate. Okay. I'll use this method min element. This should give me the position of minimum element. So max is equals to C max element e dot begin e dot end. Cool. So now I know both the positions. I just want to delete them. I think this should be what? Let's take a really large number, and if I remove both of them from left, what would be that from the left? That would be max of mini comma maxi plus one, right? Let me think about this. Yeah, if I remove both of them from the right, that would be okay. So that would be what? N minus 1 minus, let's call it mini. Can you write n minus mini here? N minus mini. So mini was that's n minus 1. So yeah, one element max of n minus mini, comma n minus what? Maxi plus 1. Isn't that again a min? Um, let's do one thing right. Mini equals to, if mini is greater than what? If is mini is greater than maxi, swap mini comma maxi. Oh, min of what? I'll say mini plus 1 plus n minus 1. Sorry, n minus maxi. N minus maxi, मतलब the max index. Seems good. I think so. It should be working. Line number 9. Here I'm getting an error. Okay. No, but what's the error here? Let's call it integer because what is happening? It might go to unsigned, etc. 531. 531. Yeah, it's correct. Resolution. No. Correct answer is what? 6, right? I want to delete 6 and 11. 6. Okay, why do I need this plus 1? Yeah, what am I doing? I don't need this plus 1 because it's already included. Should work, yeah. Okay, so you can want an integer n, okay, and people 0, 10, minus 1, and you're also given some meetings. Some xi, yi, they're meeting at time ti. Hmm. Okay, when you're given an integer first person. Person 0 has a secret and initially says the secret with the first person at time 0. Hmm. Okay. Time. Okay. Okay. Okay, this one is interesting because at time 1, these two events are happening at time 1. These two. So person 1 shares it with 2 and 2 shares it with 3 at the same time. Got it. And I want to tell which of these persons will receive the truth. Okay, if I sort them based on the time, that's the first thing. So I'll store them time-wise, and then I'll iterate over all these times. Yeah, this seems easy. Uh, any difficulty here? Not sure. Okay, what is the length of time? Okay, let's create. Okay, what I'm thinking is, can I create a global array or something? Not sure. Vectors. Got it. And answer. Okay, this is my answer. And what do I say now? So I wanted to sort it, but is it really required? Let's think about this. Okay, I want to use map here. Map int. Then we have a vectors of what? Pair. Okay, okay, okay. So now my problem is कि let's say for a given time instant, I have some meetings. Let's say X1 is meeting Y1, and at the same time X2 is meeting Y2, and so on, so on. So X3 meeting Y3. So I'm saying कि let's say Y2 knew the secret before this meeting, and he'll spread it to let's say X2. Let's say X2 occurred somewhere else, he'll spread it to some X3. X3 occurred, let's say, somewhere else, he'll spread it to someone else. Okay, so for a given number, can I say we can use let's try to run DFS, I think so. Okay, for a 2, X colon A, map of X of 2, we can just go back. What do I want to do? So I want to push X of 0 and X of 1, right? And let's make a vector in done of n initially to 0. I know done of 0 is equal to 1, and done of ff is equal to 1. Alright, so now I just have to loop over this. I could have used an unordered map. I'll use that. For every entry in the map, okay, now I have to make a graph or something, right? Yeah, how do I make a graph here? Any other way other than graph I can do this? Okay. Again, I'll use an unordered map. Let's call it adjacency and unordered map 8, 8, a visited array. So for every pair in the second part of this map, okay, in the value side, I'll say adjacency of what? P of 0 dot push underscore back P of 1, and the reverse is also true. P of 1 dot push underscore back P of 0. Okay, and then I'll pass this DFS. I'll pass hmm, okay, for auto P colon X dot if done of P of 0, then let's see DFS P of 0 comma adjacency, and I pass my listed array. If done of P of 1, what do I say? DFS P of 0, P of 1, sorry, pass my array and then my listed array. and visited.count df0. Okay, now just have to write a DFS method. Should I also pass my vector done? Yeah, I'll pass it. This should not return anything. DFS current, and this is my instance map. Let's call it EDJ, and then here ED map. I have a visited map, and then I have the done array. So if visited of visited dot count cur, it will simply return. Otherwise, for a 2x column instance of cur, if visited dot count x equal 0, I can say dfs of x instance visited done, right? So here I'll say yeah, I need to pass that visited of cur equal to 1 and done of cur equal to 1. So I'll have finally the answer, and for every index which is like 1 then of I, then I see that I have to use that index in the answer. Compile error. Where is it? Where is it? Okay, should I call it vector int? And this should be p of 1, right? Let's see. Answer really clear. Let's move this one. Okay, am I going to some kind of TLE? 0, 1, 2, 5. Okay, 3 is not part of that. Why? So I have to print it out. Okay, yeah, I have to use a map here because it should be in an increasing order, not any random order. 0, 1, 2, 3, 5, 0, 1, 3, 0, 1, 2, 3, 4, 0, 1, 2, 3. Yeah, samples always work, so let's just try to submit. Please don't give it yearly. Like I thought. Huh, what could I improve now? That's a question. What can I improve now? So because it's giving me clearly and some very random thing, I'm not sure what this is it very large or I don't have to use this. I can, oh, that's strange. I passed an error map. No, 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 I passed a correct thing. Yeah, that's correct. Yeah, what I should have done otherwise was vector int distance of let's take a number which is 10 to the power 5 and plus 100. Yeah, it's okay. So C of n, right? And what do I do here? I should not use this. This Wilson is also pretty bad. I'll not use this as well. Okay. Rather, I can use wasted one because that will be useful. This should be useful. Can remove this. And now I want to delete those entries which I just created here. Okay, in the very first thing, yeah, this is an issue. I have to do this first. Because it's giving TLE. Yeah, I got it the other day just because I was not using the reference. Let's see. Um, Compiler, why am I getting that? What is it saying? Okay, yeah, I have to remove this NC and just pass the buster. Okay, now, okay, after I'm done with that, for everything in Wisdom, turn off X equals 1. There's no passing done, I shouldn't pass done as well. This is also handled at runtime. Instruct first actually. 01235 and then 01234 0123. Yeah, I'll try to make a submission. Not sure if it will still work or not. Yeah, it worked. So there could be two possible explanations why it got really. The first one could be I didn't use a reference. So every time I was iterating over this over this array or list, I was making a copy of that element to P every time. Okay. But now I'm just referencing it. Yeah, I'm using a reference, so it's not making any new copy, just pointing to the same values. Other could be I use a global variable now. So this I've seen in Leetcode, the global variables work much faster than the local variables. So yeah, this seemed to work. It is correct also. Yeah, I mean, yeah, a lot of people have done. I shouldn't be in top 200. No way, am I in top 200. Okay, so what I did was I sorted on the base of time, and then for every time I was creating a kind of graph. Okay, so how I did that, let's say for time t, let's say for time t, we have these three pairs, x1, y1. Okay, give it some general name, x1, x3, then x2, x4, and then x2 and x3. Okay, let's say these three were the pairs, right? And before this time, let's say x2 was the person who already knew about the secret. Okay, and x1 didn't know, x3 also didn't know, and x4 also didn't know, right? So at time t, what will happen is this x2, he already knew the secret, so he'll pass it on to x4, and at the same time, okay, let me just change it again. Yeah, so yeah, that I don't have to change. So x2 pass it on to x4, and also x2 pass it on to x3. So both x4 and x3 know the secret now, but we can also see that x3 at the same time is talking to x1, right? Here. In that case, x1 will also be aware of the secret. So what I did was I created a graph out of this. So these two have an edge between them. These two also have an edge between them, and these two also have an edge between them. And finally, I started DFS from x2 and I tried to see what all nodes I visited. So all know the secret in this turn. Okay. So yeah, we do this for all the time intervals in increasing order. Yeah, that was my first mistake. I used an unordered map. Um, so we should use the map because the time now would be in a sorted order. So I'm iterating over every uh, list sorted by time, and then I find out what all the you know what all the um, pairs were. So for every pair, I'm creating an edge between them, and I'm using a kind of adjacency list here. Okay, so I used a global, right? I used a global list, and then yeah, then I also clear that list after my work is done, right? So for that many number of steps, I just delete from the back. Yeah, so this seemed to work, and yeah, it is also very intuitive. So not much of thinking over there. Let's think about. Okay, so what did I do in the first one? So this was like very standard problem. So just sort it and then okay, the brute force would be just sort it and then yeah, okay, why did I even do this? Oh no. I could have simply put a loop over the array, but yeah, this is more efficient. Um, Maybe sometime it will work in log. Worst case is still n because I might have to iterate over all the n elements. Okay, I use a method called equal range. So what this method does is it will give you two pointers, one for the lower bound and one for the upper bound. And I pass my target, and I also sorted the array before this. So all I have to do is now that pointer, no, I mean the pointer for the lower bound minus the base index. I start from there and I go till my second index, which was given by equal range. So equal range actually gives me a pair, right? So this will give me, let's say, P1, P2, and these two are actually pointers in the vector array. So that's why I'm doing minus a dot begin. So now when I subtract the base index of the vector, then it will give me an absolute index. So this will be one index and this will be the other index. And I'm doing a less than and not equal to here because this will be upper bound. So the first element which is greater than 2. So if you see in here, so for this it will give me this range. So this will be the upper bound and this is the lower bound. So I want these two indexes. That's why there's no equal sign here. Let's see. Then, yeah, I don't know why I messed up here. Again, I could have saved like at least 5 to 7 minutes here. Okay, so essentially what I finally did was I created a prefix array. So this prefix array is basically the sum of prefixes of A. Yeah, and my first mistake was I used an integer. So because we have all the numbers equal to, let's say, maximum 10 power 5, and we have 10 power 5 numbers, so the sum of all those numbers would be 10 power 10. So that's already overflowing integer range. Okay, so yeah, so we store all the prefix sums, and then for then I create an answer vector, and then I initialize with it -1 because that's what I need. I need -1s at a lot of places. Okay, so yeah, I start from k, the first index, and then go till n minus k. So I start for k equals 3, I'll start from here and go till here, 9, 1, and 8. So for this index, what I want is I want the sum of previous three element and the next three element. So that's what I did. So prefix of I minus prefix of I minus k minus 1. So this is nothing but I'm talking about this sum, previous three plus itself. Okay. So yeah, this is the left side, including that number. And then the right side is prefix of I plus k minus prefix of I. Nothing but this element minus this element itself. Okay. And then I just add those two number up and divide by 2 times k plus 1, which is the length of the segment I'm talking about. Nothing but if we're talking about 9 as the middle element, then that should be, yeah, this part, 2 times k plus 1. Okay, so yeah, again, I made a very stupid mistake here. So essentially, what you are given is we have so all these numbers are just string. So we have to delete the smallest and the largest number in the array. And how do we do that? We have only two kind of operations. Delete from the left or delete from the right of the array. Okay, so for this case, I think the optimal way is you delete 2 first and then you do 10. And from the right side, then you delete 6, 8, and 1. So both 10 and 1 are now deleted from the array. So the number of steps it took me was 5. That was the minimum. Okay, so in this case, I want to delete -4 and 19. So I can just delete 0, -4, and 19 from this end only. I didn't worry about the other end. So yeah, this is the minimum. Okay, so what I essentially did was I used a method in STL, which is min element. So this min element method, if you pass in the array or you can use a vector as well. This will give me the pointer to that position which has the smallest value. Okay, now I'm not dealing with pointers, so I'll simply subtract the base index of the vector. So this will give me an absolute, absolute index, right? So for minimum, I'll have an index, and I do the same for maximum value as well. Now I'll have three conditions. The first condition is I delete both the numbers from the left. So for this, what I'm talking about, the first condition is I delete 2, 10, and then 7, 5, 4, and 1 from the left. I don't even worry about deleting from the right. I'm just deleting from the left. Okay, this is the first case. Second case is I delete everything from the right. So that would be 6, 8, 1, 4, 5, 7, and then 10. Okay, because I've covered both the number 1 and 10, so yeah, I'll stop here. The other one would be you delete some part from the left until you meet the first one, and you delete the same number, not same number, you delete from the right for the second number. So the answer would be minimum of these three cases. My mistake was I think I used a plus one here, which was bad. Why bad? Because so let's say mini was n minus 1. So n minus 1 is 1, which is correct, right? Because if I want to delete the, let's say, last element, my value should be 1. So that is n minus mini, which is correct. No, there shouldn't be a plus 1. So yeah, I swapped these two because the case could be, yeah, just like this. So the minimum is after the maximum. So yeah, I just wanted to, normalize things that, the first index is the smaller index, not the smaller element itself. Okay. So in that case, min index plus 1 would give me how many I need to delete from the left, and n minus maxi, which is the right side index. So this will give me how many I want to delete from the right side. And I take min over all three, and finally I'll have my answer. Okay, this countess that didn't go my way at all. I'm already 300 plus, I think so, because I made three penalties, I think. Yeah, I should be 300 plus. Actually, 440. That's more horrible. Hmm. No worries, but because I had a good contest yesterday, so that should compensate for this one. Did horrible, yeah. I mean, three penalties and three problems. All right, yeah, that's it. Thanks for watching.